this idea of the fundamental theorem of calculus is going to be an important part of the remainder of the course. So we want to get really good at solving or be really skilled at solving these definite integrals. So these next few videos are all examples worked out. As you're going through them, you try them with me, or you may even want to pause it and see if you can move ahead and try it without me, and then check your work based off of what you see in the video. With example number 2, we have the definite integral from -1 to 1 of 4 minus x squared dx. Again, first step, take the antiderivative. So the 4 antiderives to 4x, and the x squared derives to x cubed over 3. Okay, those are just our basic antiderivative rules. We still need our bounds, even though we no longer have our integration symbol or our differential. They're gone because we've done the antiderivative. All that's left is just the function. We're going to plug in the top bound first and the bottom bound second. So we plug in the 1 first. So we're going to have 4 times 1 minus 1 cubed over 3. And now what I'm going to do here, I'm going to wrap this in parentheses because I'm going to subtract the second item, and we want to make sure that our order of operations are not screwed up at all. So now I'm going to parentheses again. Now I plug in the -1, so that's 4 times -1 minus -1 cubed over 3. Okay. Now this is a correct answer right here. And on the free response portion of the exam, if you have to solve a definite integral, you can actually stop right here. Okay, you don't have to simplify your answers. This is in the multiple choice section, which a problem like this would be much more likely to be in the multiple choice section. You want to be ready to have 4 answers that are simplified versions of this. So let's go a little bit further here. We have 4 minus a third. All right, so 4 minus a third minus, and then we have -4, and then we are subtracting -1 over 3, so we're actually adding a third here. 4 minus a third is 3 2/3. Then we are subtracting the -4 plus a third is -3 2/3. So we're actually subtracting the same, we got a double negative here, which means we have a final answer. Well, if we add these, 3 plus 3 is 6, and 2 plus 2 is 4. So we have 6 4/3, although we tend to write that as 7 1/3. All right, so there's our first answer for problem number 2. For problem number 3, we have 3 times the e to the x is our integrand. We have to antiderive that. Well, 3 is a coefficient, so that's going to move right into our antiderivative. And e to the x, well, e to the x antiderives to itself. So we have 3e to the x. And again, we can always check this by taking the derivative. What's the derivative of 3e to the x? Yeah, it's 3e to the x. So this is fine. We've done our antiderivative. Now we have our 0 and our natural log of 2. Those are our 2 bounds. We're going to plug our top bound in first. So we have 3 times e to the natural log of 2 minus 3 times e to the 0. And we got to do some simplifying here, although this is a correct answer. You want to be ready to use your pre-cal skills. E to the natural log of 2, we know that that simplifies. They wipe each other out. They are inverse operations, similar to the derivative and the integral. So this is going to simplify to 2. So we have 3 times 2 minus 3 times, we know that anything to the 0 power is 1. So 6 minus 3 gives us a final answer of 3. Okay. Now with these problems, with the rest of the problems on the page that we're about to do, and these future definite integrals, keep in mind that you could always check your answer by using the Math 9 command on the graphing calculator. You have your graphing calculator available to you. Get used to using it. You may not be able to use it for every problem on the test, but that doesn't mean you can't practice using it now, so that when you can use it on the test, you do feel comfortable using that Math 9 command. I will look to put a couple videos up as well, which would help with the calculator skills.